So when you can answer you can answer it easily, don't go for complicated answers. So this is all about Dobrynin's triads. They were not of much use. The next person who gave his own theory of classification of elements, and who was definitely better than Dobrynin because he classified more than just 9 elements, he was Newlands. So Newlands, he classified elements from hydrogen to thorium. Thorium is the 56th element. Don't need to memorize all this. Hydrogen is the first element. So better on the safer side, you just memorize it was from hydrogen to thorium, and it consisted of 56 elements. Because you never know what might be asked in an examination. So what he did was that he wrote the elements from, suppose 1, 2, 3, 4, 5, 6, 7. And then after 7, 8 he wrote down below 1. These are the elements. First element, second element, third element, fourth element, fifth element. So after 7 he wrote down 8 over here. And then he continued like that. 8, 9, 10, 11, 12, 13. Oh sorry, 14. 14, then 15 over here. So what he did was basically repeat the cycle after 7 elements. And what he found out was this 1, 8, 15. These elements showed similar properties. And similarly 2, 9, 16, 3, 10, 17, all these also showed similar properties. So he gave his own law, which is known as the Newlands law of octaves. You know what octaves are? Octaves, they are the musical notes. They are nothing but musical notes. You have heard in Hindi they are like sa re ga ma pa dha ni, and in English they are do re mi fa sol la ti. So why he called it octaves? Because octaves also contain 7 notes. And after 7 notes, again the first note comes. Like you have sa re ga ma pa dha ni, and then again sa comes. So just like that, in the Newlands law or in the Newlands classification, he repeated the 8th element after each 7 elements. After 7 elements, he repeated the 8th element. So that was Newlands law of octaves. So if they ask you what's Newlands law of octaves, or the definition of it, you can write that Newlands law of octave is related to the classification of elements such that after each 8 elements the elements show similar properties, similar physical or chemical properties. You can modify this definition and write, of course, just a crude definition. So what he did was he placed hydrogen, then there was lithium, then there was beryllium, then boron, then carbon, nitrogen, oxygen, fluorine, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, potassium, calcium, chromium, titanium, manganese, iron, and then what he did was he put cobalt and nickel in the same place. So he just tried to adjust the cobalt and nickel, because they shared similar properties, into hydrogen, fluorine, chlorine, that group. Then he had copper, zinc, yttrium, indium, and then so on. You don't need to memorize so many things. But the thing was that lithium, sodium, calcium, these all shared similar properties. So similarly, beryllium, magnesium, this was potassium. So beryllium, magnesium, calcium, they showed similar properties. So this was another way of classification of elements, and he went up till thorium, which is the 56th element. And so this was another way of classification, but this also had its disadvantages. Now, what were the disadvantages? The disadvantage was, this had many disadvantages. Although it was a good attempt for classification, but poor Newland. So the first disadvantage was that it was valid only up to calcium. No, after this thing, after calcium, the pattern did not repeat itself. He tried to place the 8th element after each 8 elements. The elements did not show similar properties. They showed similar properties only up till calcium. And that was the point till which the law was valid. So all these cobalt, nickel, copper, these did not show similar properties as their other group members. Let me write that thing again, because I'll be needing it again and again.